Hello students. So we continue with our topic, that is data mining. In the previous class, we have studied about what is data mining, what is the need of data mining, and what are the applications of data mining. Now today we will discuss what are the tasks that we perform during the data mining process. Usually we have a data, and that is a large data, mountain of data, present gigabytes. But we have to extract out an important information from that data that is useful to us, that is required by us, or that is an information which is easily interpretable or understandable regarding any kind of task. So basically, we say that there are 6 common classes of tasks that we can perform during the data mining process. So during the data mining process, you get to know about various types of things that we can analyze and make the data more interpretable or understandable. The first one is anomaly detection. So once you are analyzing the data, you can come across a data that is a very different from the rest of the data. That is an unusual data record. And or this may be a data error that requires further investigation. Such data, which is an unusual data record or data error, this doesn't help our model, our prediction model. This unusual data record, data error will only hamper the quality of our model. So we need to remove such unusual data records in data errors so that our model is good for any kind of prediction. Such anomalies are also known as outliers, change or deviation detection. Basically, they're known as outliers. Suppose we have a data of students in the class. Suppose there are 100 students and every student is getting more than 90% marks. So 99 students got more than 90% marks, but there is a single student who got 1 mark only. So we cannot say that the class is performing very poor because a single student have got 1% mark. We will say 90%, 99% have got more than 90% marks, the class is performing very well. So this 1%, the student with the 1 mark, this is an unusual data record. And if we use this, it will only hamper the model of the class. So such types of record which are unusual or are data errors, they might be interesting for future investigations that require for investigation, but for predicting a trend or a behavior, such unusual data record or data errors must be removed. So important task in doing a data mining process is to detect the anomaly. And such anomalies are normally known as outliers, change or deviation detection. Main thing, they are known as outliers. So our data which is unusual and is different from the rest of the data present is normally known as outlier. This is a type of anomaly and we need to detect it and we need to remove it while building a model for any kind of prediction studies. Second is, while you are working with data, we should use association rule learning. We have the data, we have to see the dependency modeling. We have to see what kind of data are related to each other. For example, in a supermarket, we can gather a data or consumer purchasing habits, at which products are frequently brought together. For example, a Colgate is brought together with toothbrush. For example, a soap is brought together with a detergent powder. For example, a cloth is brought together with a detergent. So these are the related type of products. So we need to find out the related type of products. This is known as market basket analysis. And this comes with association. So we have to find the associated data. Third thing we can do while you're working on data mining is clustering. Need to cluster the data. We have to discover the groups and structures in the data that are in way or another similar. You have to cluster. For example, the big bazaar market, you have the grocery section, you have the clothing section, and you may have the bag section. Further in the grocery sections, you may have the staple foods, you may have the cosmetic items. So these types of clustering is done in the supermarket also, so that we are able to deal with the data very importantly. For example, if you go to big bazaar and everything is spread around, there's some footwear put there, there's a cloth put there, there is grocery lying there. So you do not know where to go and what to find. But simply when it is properly clustered, you simply go to third floor, you get the grocery. You come to the second floor, you get the clothing section. You get to first floor, you get the required section. So clustering is another important thing that should be done in the data, so that similar types of data, this similar type of things are available together. Then when we are working on data, we should have classification. For example, this you can understand with the help of a mail. For example, you all will be having a Gmail, and you have, when you open the Gmail, it has three sections: primary box, legitimate, spam. This type of things are there. Why? For example, spam mails. These are also the mails, and they keep on coming in your primary inboxes. So what happens? Suppose you have 10 primary mails and 10 spam mails. So you get confused. You are also opening the spam mails, and these are not required for you. These are not necessary. But if a Google or a Gmail very easily classifies the mails that you're getting as primary mails, as legitimate mails, or spam mails, it is easy for you to look for important mails, to look for spam mails, or look for the illegitimate mails. So this classification is important so that you can get to know about your desired data in a most useful fashion. Then regression, you would have heard about in statistics, correlation and regression analysis. So regression is a type of function which is used for modeling the data with least error. You have to model data for least error. For example, if you need to predict something, for prediction you need to have a model which will predict it. And model, a prediction is never 100% accurate. It has some error. But if you model a least error, it is a good model to predict anything. So to predict any trends of behavior, we need to model the data using the past information that we are having, so that it can predict the trends and behavior of the forthcoming data. It can help you, it can be used for forecasting the data, and this should be modeled with least error. And the last thing is summarization. So whatever data you have to you are having, you should have a compact representation, including visualization, report generation. It doesn't mean that you're seeing an attendance sheet and in that your marks are also present, your mid-semester marks are also present, your assignment marks are also present, your CV is also present, your BSc mark sheet, your high school mark sheet, everything should be classified properly and should have a compact representation. And you should have a proper visualization or report of whatever data you are having. It should be a compact representation, proper visualization, report generation. So during the data mining process, we usually perform these six common tasks. First, while working on the data, you should remove the anomalies, that is the unusual data records. Then you should associate the data that are important with each other by using association rules. Then you should cluster the data that are one way, another way similar to each other. Then you should classify the data. These are all things are different things. It doesn't mean that they are same. Association different, clustering different, classification different. For example, you classify the mail into legitimate or spam, and you then need to build a model to predict trends in behavior, least error, and summarization. A compact representation of data is required during the data mining process. So these all um, things are important so that you can do the proper data mining things. So architecture of data mining, you can see here. As a user interface, we evaluate the patterns. There's a data mining engine, we do all the such tasks, and then cleaning, integration, data is then data is sent to the database. Then we send to a data warehouse on the World Wide Web or the other info repositories. The data can be sent. For example, this data can be present on in a particular database only, or it can be present on data warehouses where number of databases are present, or it can be present on net or other information repositories such database can be present. There are some terms which are important while discussing data mining. Knowledge base. These are simple things. You get to the notes, you will understand it easily. Knowledge base. First of all, you need to have a knowledge base. You should have a domain knowledge. You should have the basic knowledge of the data. You should have the data and you should have the knowledge about the data. For example, you should for a very kind of market analysis, you need to have the data of the market as well as you need to have the information about the data of the market. These two things are different. So first primary information for carrying out any data mining or data discovery, you first thing is we should have a knowledge base. We should have the data and we should have the information about the data. Second is data mining engine. Whatever data mining you are applying, it may help in characterization, association, correlation, classification, prediction, anything. And then when we have got that, then we need to evaluate the patterns and what specific information we are going to retrieve from it. And once it is retrieved, important that this should be present in the user interface. For example, you carried out a market search analysis of a big bazaar store. You had the knowledge base. That means you have the information about the big bazaar. You have the information about what kind of data is stored in big bazaar. Then you perform a data mining. And from that, the third step, you evaluate the pattern. But finally, if you're not being able to present that data to the user, then this all data is useless. So you need to have a user interface. That means a visual user interface. It should be present in a compact representation, a picturization on the graph form that the user or any end owner may understand that what the important information has been derived out from the data mining studies. So these 6 tasks that we have discussed in data mining process can be accomplished via this process. So whenever you're going for data mining process, so this is another short thing that we are going to discuss. We already know that data mining is the process of discovering various models, summaries, derived values. Whatever you say, you're mining the data. So what you should do while you are carrying out data mining studies. Simple, again, an example of big bazaar. You have the big bazaar. You have hundreds of, you have thousands of big bazaars all over across India, and you have 10,000s of counters, and we have millions of purchases. Then what we should do? How we should perform the data mining process? First, you should know if you're working on a big bazaar data, you know it's a large data, then how will you perform data mining? How will you perform? So first thing is you should know the problem and formulate the hypothesis. You have the data, you have the everything, you have data science expert, everything you are having, but you do not know why you are doing the data mining. So your problem should be stated very clearly, that for what purpose you are carrying out the data mining. And for solving that problem, you should formulate a particular hypothesis. After that only you will be able to get your information. So having the data is not a great task, but working on the data is a great task. So to work on the data, we should first of all know what kind of problem we are working upon. So domain specific knowledge and experience are usually very necessary. A person from biological field, how can he understand that what should be bought and what should be purchased at a big bazaar store? An expert is necessary. So domain specific knowledge and experience. Knowledge as well as experience both are very necessary to state the problem. Unfortunately, many application studies tend to focus on data mining technique, but at the expense of clear problem statement. They do not have a clear problem, but they are doing a data mining. So for clearly stating a problem, that why you're data mining, you need to have a domain specific knowledge and you need to have the desired experience. So that firstly, a specific problem is being stated. After that, only data mining technique can be applied to formulate a particular hypothesis. That is a close interaction between a data mining expert, which will mine the data, and the application expert is important. You have the data mining expert, but you do not have the application expert. That is useless. The application expert will only tell you what is the problem and what hypothesis will formulated. Then only data mining expert will work accordingly. So this is an interdisciplinary field. This is an interdisciplinary field. So once the application expert gets you the data and gets you the problem and formulate the hypothesis, the data mining expert, what does it? It collects the data, start collecting the data. And it's important how the data is generated and collected. Data may be presented in two forms. Maybe under the control of an expert, which is an expert. This is not a designed experiment. For example, a big bazaar data. You know that an expert will always have his data. You know, whatever data is being created all over India, you will get the data automatically. And it's a designed experiment, and he knows what kind of data is coming. And second is, expert cannot influence the data generation process. This is known as observational approach. For example, COVID data. Suppose one is working on that COVID data. So that expert do not have an influence on the COVID data. The data may come, the data may not come, the data may be accurate, the data may be inaccurate. The number of features, the number of parameters present on the generation of data. So data may be present in the two forms, the form of designed experiment and the form of observational approach. So whatever is the form, we need to collect the data. The data is used for estimating a model, then model is being used and data use data for testing and applying to a model. So once you have the data, then you should process the data. So if we, I'm going to discuss it again, what you're going to do. So whenever you're performing a data mining studies, first you need to have a domain specific knowledge and expert, an application expert who may state the problem and formulate a hypothesis. And once the problem is stated and form a hypothesis will be done, then you collect the data. The collected data may be designed experiment type or an observational approach. Once we have the data, we have to process the data. What we have to do? We have to detect the outliers, unusual data records. These may be due to measurement errors, due to coding, recording, sometimes natural abnormal values are present, non-represented. These are non-representative samples. We need to detect it and remove it. So we can detect and eventually remove outlier, or we can develop robust modeling methods that are insensitive to this outlier, that are insensitive to it. So once the data has been collected, it is processed, outliers have been removed. Second, you have to scale the data, encode the data, and select the features that you have to work about. What is scaling? Suppose one feature has range of 0 to 1, another has range 100 minus 100 to 1000. They will do not have the same weights, but you have to scale it accordingly that 0 to 1 comes in the same scale as minus 1 to 1000, 100 and 1000. So scaling of data is important. For example, your marks are being scaled during the mid-semester examinations. You're scaled that grace marks has been provided so that everyone passes in the mid-semester examination, or whatever strategy is being applied to make the students comfortable who have not scored a good marks in the examination. That is a different thing. So scaling and coding is important. We have to scale the data. We have to be a range of minus 100 different types of data present. We have to weight accordingly. Scale them and bring both features to the same weight. Second, application specific encoding method should be present. It doesn't mean that any kind of application is present and you are using the same encoding method. As application specific encoding methods should be present. So once it also will be done, you need to build a model through regression techniques. And once the model is being built, then what happens? Then you have to interpret the model and draw conclusions. Data modeling model should help in decision making. This model should be such that whatever result they produced, it should be an interpretable and understandable. Should help in decision making. And the goals of the accuracy of the model, the accuracy of its interpretation are somewhat contradictory. I'm saying that the goals of the accuracy of the model and the accuracy of interpretation are somewhat contradictory. That is what I usually say in the bioinformatics lab. For example, you are performing a blast experiment, a FASTA experiment for sequence alignment studies in your lab. So you got a sequence and you're carrying out database similarity searching studies using BLAST, basic local alignment search tool, or FASTA tool. So when you do this, what happens? You get the results and you are very happy with it. That a single click gave you a result. So the accuracy of the model was good. The result came out, but you do not know what is interpretation. What is its actual interpretation? It might be true, but you're not understanding. So the goals of the accuracy of the model and interpretation should be related to each other. They should be not be contradictory. Simple models are more interpretable, but they are less accurate. So we need to make the complex model very diligently so that which are more accurate and sensitive to every kind of data. So what we have to do, we have to state the problem first of all, formulate the hypothesis using application expert, then we need to collect the data using the data mining expert. We have to pre-process the data and then estimate the model, interpret the model, and draw the conclusion. This is the entire data mining process. Okay. Next, and this data mining classification, these are simple things, not to get into details much. Data mining can be applied to various kinds of disciplines, and data mining can be performed according to kind of databases, kind of knowledge mine, kind of technique applied, kind of application. You can classify the data mining into different types of categories. So these are just simply theoretical things, not much to discuss. What are the major issues while you are performing the data mining? Major issues is mining different kinds of knowledge in databases. So it is necessary for data mining to cover broad range of knowledge. broad range of knowledge should cover. The need of different users is not the same. So whatever, for example, whatever I'm teaching, the need of every student is different. Somebody would be having just so that he can get notes for it. Somebody would be looking so that sir can easily explain it. Somebody would be looking forward that we can get extra notes for it. So need of every user is different. So whenever I'm teaching, so I have to keep in mind the need of every student. So it is necessary for data mining to cover the broad range of knowledge, broad range of necessities. And there should be interactive mining of knowledge at multiple levels of abstraction. So the data mining should be interactive. We should allow the users to focus the search for patterns, providing and redefining data mining request. That means, for example, you analyze certain data and you got the result, but you want to change the parameter and get whatever results come. So users should have the option where the user should have the interference in the data mining model, so that she can change the parameters of the model, and accordingly he can predict the outcomes of the model. So that should be interactive mining. And incorporation of background knowledge, very important. You should have the background knowledge. Past data information is very important. If it is less, the data mining model will not be good. And data mining language should be integrated with the data. Whatever the language, computer language you're using for data mining study, it should be well integrated so that it is being easily merged or integrated with any of the data warehouses available on the public platforms. Presentation and visualization of data mining results. Presentation should be good, visualization is good. So this is an issue, because the presentation and visualization should be very good, because you always want to see the clear things that is simply understandable. And you should handle the noisy or incomplete data also. Data cleaning should be very necessary. Data mining should do good pattern evaluation. Good efficiency should be there. Good scalability to be there. And one important thing is should be parallel distributed incremental mining algorithms. The algorithm should divide the data into partition, which is further processed parallel. So it can be in the form of incremental algorithms. For example, you're going to big bazaar store, so you can have three types of data. You can have a grocery data, you can have the clothing data, and you can have the general data. So these are three different things. So you can say we have the parallel data. So algorithm can be divided into partitions for one grocery, for one clothing, and one for general. But these are processed parallel, and these all three things are merged to get a combined result. So this is a type of incremental algorithm. One algorithm is at the grocery level, one algorithm is at the clothing level, and one algorithm is at the general level. But these are being parallel and distributed into partitions, but these all merge together to perform the final task. So these are a class of incremental problems. So this is again on a big term, it is known as KDD. This is important: knowledge discovery in databases. So data mining, we often say that this entire step that we have discussed, data mining is a part of this step. And the bigger term is knowledge discovery in databases. But we simply say that data mining, this graph you can see there, this is knowledge mining, knowledge in discovery, knowledge discovery in databases. We have the databases, we clean it, we select it, we data mine it, and we then go for pattern evaluation. We have the databases, we select it, we clean it, we mine it, we collect the patterns, and we produce a knowledge. So this is knowledge discovery in databases, also known as KDD, knowledge discovery in databases. And for the knowledge discovery in databases, the important thing is you need to perform the data mining. So actually data mining steps, these are the pre-steps, these are the post-step. And entire this step is known as knowledge discovery in databases, KDD. And this again needs a databases, cleaning integration of the data, then selecting the data and the data mining process, evaluating the pattern, generating a new knowledge. And this combined term, which is known as knowledge discovery in databases, an important part of it is the data mining. So by using data mining, you can simply do the knowledge discovery in databases. That's all the student you should know regarding data mining. The notes is available on the Google Classroom. If you have any problems or query, you can simply ask there only on the Google Classroom. Thank you very much. Best of luck.